My name is Sean Smith. I'm a product manager with the GraalVM team. And today I'm joined by Oleg Shelayev, who's going to talk about running Apache Kafka with GraalVM for benefits in terms of the cluster and the clients and another few interesting topics. So Oleg, do you want to introduce yourself a little bit?
Hi, Sean. Thank you. My name is Oleg. I'm very happy to know that all of you are listening to me here. I'm a developer advocate on the GraalVM team at Oracle Labs at Oracle, the team which develops Oracle GraalVM Enterprise Edition. And today we're going to talk about Apache Kafka, indeed, and the opportunities how you can get the best benefits from the powerful runtime as Oracle GraalVM Enterprise Edition is. Right.
Yeah, so this is a really good topic because a lot of people run Kafka. Obviously Kafka is very demanding in terms of performance. So what we'll do is I'll pass it off to you, Oleg, and then when you're done, I'll come back in and we'll just take some Q&A from the audience. So people who are listening, get ready to ask a few questions. We have a Q&A box that'll be available to type in your questions. So with that, I'll pass it to you.
Thank you very much. Very well. Let's get going. This webcast will be approximately half an hour, so we'll spend a little bit of time on the content and looking at the slides and demos, and then we'll proceed with the questions as Sean helpfully suggested. So let's get going. First of all, please know that this is the technical presentation and do not make any forward-going business decisions based on this. And also some components of the GraalVM Enterprise Edition are distributed as the early adopter technology, so be aware of that. To understand GraalVM Enterprise Edition and to understand how Apache Kafka can benefit from it, you need to know that Java as the platform powers absolutely ridiculous number of devices and absolutely ridiculous number of applications and enterprises in the most business critical conditions. Right? You can find Java everywhere, and more Java applications in the ecosystem are migrating towards using the microservices architectures where the different components need to talk to each other. That's where Apache Kafka comes in as the messaging platform, as the distributed stream processing platform, and we're going to talk about the combination of those. So Oracle GraalVM Enterprise Edition is a high-performance runtime and digit compiler that enables you to write your applications and make them faster, smarter, and leaner, which is an excellent combination of things. What is GraalVM Enterprise? What can it give you? It gives you the high-performance optimized just-in-time compiler for your Java or JVM languages applications. That means that you can run your Java applications, and when the time comes to the point where the virtual machine says, I need to optimize this code, please give me the most optimized machine code that you can imagine, the just-in-time compiler will provide that. And the GraalVM Enterprise includes the state-of-the-art just-in-time compiler. So it gives you really, really good results. And we will see that for a variety of Java workloads, and that includes, of course, workloads that use Apache Kafka. GraalVM Enterprise also includes the ahead-of-time compilation technology called native image, which can process your Java applications and then provide you with a native platform binaries, which do not depend on the JVM to run, which start up in really, really short times, like milliseconds, and which consume a lot less memory than normally you would expect. So they're really perfect for the microservices deployments, to work in the cloud deployment environments, to work in the constrained environments like Dockers. So this is where you can benefit from compiling your Kafka clients, your applications using Kafka for the messaging services, not the Kafka cluster itself, for those low footprint environments. And then, of course, GraalVM Enterprise is a polyglot machine that is capable of running applications in different languages. And there are certain use cases where this comes handy, specifically for communicating with third-party systems like the Apache Kafka cluster from your applications. You can use the variety of languages. And you can also use the common battle-proof and battle-tested libraries from all of the supported languages. So we'll talk about a little bit of all of those three use cases through the presentation. So the just-in-time compilation. This is probably the most straightforward application of the GraalVM Enterprise as a platform. And just to make use of that with Apache Kafka, you just need to run your Apache Kafka application on the GraalVM Enterprise. How to do that? You need to know at least a little bit about the Apache Kafka. So Apache Kafka is a streaming platform. It consists of two main components, right? There could be different types of those components, but two main components. There is a cluster, which is at the center of the processing, which is the platform that your components, your applications, or your stream processing software connects to. And there is a client, which are on the picture are the applications of the stream processors or the databases. And they all connect to the Kafka, and they all can send and consume messages from the Kafka, making it making use of the real-time data handling and the stream processing capabilities of Kafka. Right, so server, cluster, and the clients. The clients are what you built into your applications. Normally, you do not modify your Kafka cluster. You can use Kafka cluster as a service, and a number of companies offers that. But what you control is typically the applications. And the Kafka API that are interested and that you use in your applications are the producer and consumer for respectively creating the messages that you send to the Kafka and subscribing to topics inside Kafka to receive the messages created by other producers. So just the basic send and receive messages. There's also the Kafka Streams API, which allows you to process the streams of data within your application. So think about this in a way that unlike in a database, when you can call like a stored procedure and process data in the database, in the cluster, with using Kafka Streams, you pull the data into your application and process that using your application resources. And then there is also the connector and admin API, which are used to connect to data stores and to administrate the cluster. So for your applications, you want to concentrate on the first three. This is the most commonly used Kafka APIs, and this is what you can speed up by using the just-in-time compiler from Oracle GraalVM Enterprise. How does it look? You just run your Kafka application on top of the Oracle GraalVM Enterprise, and the just-in-time compiler will be enabled by default in itself. So let's take a look at a sample Kafka application. And this would be a web application using Micronaut web framework. And we're going to just create the basic client that will be able to send messages to the Kafka server, to the Kafka cluster, to the particular topic called My Products. And we will subscribe from the same application. We will subscribe to the messages from that topic, and we will receive the messages, print out the contents of the message, and then just exit the application. This is not normally in your applications, of course, you will not exit upon receiving a single message. But sometimes you might want to do exactly that, specifically in all kinds of serverless deployments, where you need to process a single Kafka message or a single HTTP request and send a bunch of Kafka messages in response to that. So let's see how to run a Kafka application on Oracle GraalVM Enterprise Edition. So this is a short pre-recorded application video. You can see that this is the Micronaut application. It's a simple class, and it is using Micronaut web framework. What we did here is we leverage the Micronaut Kafka integration, which offers us ability to create normal bean-style elements, components, and declaratively connect them to certain Kafka cluster. So we specify the Kafka client and with the topic, and we also have the listener that will receive the messages on top of that. So there are two basic components in this application. It doesn't even use the HTTP handling capabilities, but it does include the HTTP server. So it's a full-blown microservice that will start everything, that will start listening on a port, and then it will send a message to Kafka cluster, and then it will receive the message from Kafka cluster, and then will kill itself. So we started the Kafka cluster using the Confluent platform, and we use the provided example script using the Docker Compose. It takes a little bit of time, so we did it beforehand, but it starts a bunch of services, including a single broker, which is the Kafka instance, and, for example, this command center control, which shows us some stats. So we can see our Kafka cluster is running. It's healthy. It is processing some data. It's ready to process some data. So now we're going to run the application, and we will create a topic, because we need to create a topic. This is the Kafka abstractions for the stream of data to which you can send and receive messages. So we just create that. Messages are, of course, the key and the value. So you can serialize any objects that are serializable to send the Kafka topic. So when we run this, we use the normal Java command line utility, right? So the Java utility from the JDK distribution. And you can see in this particular case, we have Java from the GraalVM Enterprise Edition distribution 20.1 version, and we can just run our Kafka application normally through using our Java from GraalVM. And it will run out of the box, and it will do the necessary things, and it will connect to the Kafka cluster, and it will send a message to Kafka cluster, and then it will receive our hello world message from the Kafka cluster, and then it will just shut itself down. So you can see it starts fairly fast. Micronaut is a great framework, so the startup time for this is a little bit over 2 seconds. But the main point here, that GraalVM provides you with a compatible JDK distribution, so you can run your applications, including your Kafka applications, on it just by changing the command line utility, the path to your Java utility that you use to run your applications. And it runs, right? And you can see that indeed in the control center, we can see that into our topic, my products, we sent 2 messages, and the offset in the topic has changed to run up to 2 messages. Right, so it indeed showed the integration and how Kafka worked with the demo application here. Right, so now the question is, does it actually become faster when you run Kafka on GraalVM Enterprise Edition? So what we did, we ran some synthetic, and by we, I mean I personally run this on the same cloud machine that you saw me running this example application, which is a fairly powerful but not extremely overpowered cloud machine. It has something like 64 gigabytes of RAM and 8 CPUs. So it's like a decent developer workstation sort of machine. And I run the Kafka in the Docker containers, and I run the simple benchmark that just generates messages and in a loop sends those messages to the Kafka cluster using the asynchronous API for sending them, and just flushes the buffers so the messages actually end up in the Kafka cluster. So I run this using OpenJDK 8 update 252, and I also run the GraalVM Enterprise 20.1 edition based on JDK 8 to make this comparison as comparable as possible. And notice that this is not the most scientific. It's a little bit of synthetic benchmark, but it shows that the GraalVM Enterprise Edition gets numbers a little bit better than the OpenJDK baseline that we have. And this is the units of measurements are operations per second, so the higher score is better. So we get a little bit, approximately plus 5%. Normally, this number could vary from a number of factors. One of them is the complexity of your message that you sent. So this was a very minimal message consisting just of the string key and the long value. But the dominant force in this workload, the thing that dominates the performance, is actually networking and serialization. So you need to understand that if you just think about the individual sending in the individual message, one message to Kafka cluster, then there is not very much opportunity to optimize that much better than the existing solutions. However, when your application gets more complicated, when your messages become larger, so you need to serialize them, you will see better gains and better performance improvements. Right. And we know that because we run a bunch of benchmarks. And so one benchmark suite that we reference and we like to reference is the Renaissance suite, which uses the modern application libraries and modern Java JVM code that maybe other benchmark suites do not exercise to the fullest. And you can see that the GraalVM Enterprise here, comparison to the JDK 8, has a decent speed up. And in the 20.1 version, it's approximately 50% faster on the composite score. Right. So that's it. And main takeaway is that you can run your applications, your Kafka using applications on GraalVM, and it will be faster. And you can run them out of the box. Now, the second thing that you might be interested in is the ahead-of-time compilation. And this perhaps is more interesting for the small applications that just do one or two requests, send one or two messages to Kafka. So GraalVM native image can produce the platform binary, the executable binary, that will consume much less memory and will be much faster. So let's see how it works. I took the same application, right? This is the same application that we had. And this is, we can look at that application compiled as a native image. And we can see that it's a file and that it's linked to the platform binaries, right? So it doesn't depend on the JVM. And we can time the execution of that application. And it will do the same thing. It will start the thing. It will send the message to the Kafka cluster. It will receive the message from the Kafka cluster. And it will stop itself. But you can see that the timing for this is 57 milliseconds for doing the whole life cycle of starting the application, sending messages to Kafka, receiving messages to Kafka, and from Kafka, sorry, and processing those. So this means that your applications that use Kafka, producers and consumers, can be compiled to native images and can be used in the cloud deployments where memory consumption and the startup are essential. This is a much better way to deploy your applications than using other normal development means. So just to reiterate, the two benefits that we saw in the video is a really fast startup time, which allows you to scale your applications to 0, and really fast startup time. Yes, that's the same thing. One of those things is the lower memory consumption, but it's not depicted here. Excellent. Wonderful. Right. So let's go to the other part of the Kafka infrastructure, is the Kafka cluster. And you can also run Kafka cluster on GraalVM Enterprise, and it also will show the performance benefits from doing that. So to illustrate this concept and how to do this, one way of how you can do this, I took the same Docker Compose script that we used for creating this Config platform environment for the demo purposes, and I changed the server, the Docker image that is used for creating the Kafka broker, the thing that actually processes our messages sent and received to Kafka, right? The heart of the Kafka cluster. I changed it in the following way. I added the GraalVM Enterprise Edition to it, and I set the Java from the GraalVM Enterprise Edition as the default Java executable. And the base server is absolutely the same, and we just added one folder, and now when we run the command line script that will run our Kafka, it will use the Java from the GraalVM distribution. Fairly simple. With this simple change, which is literally a 4-line Docker file, we got the following test results. So we did the short performance evaluation of this. And again, this is a little bit synthetic benchmark, but this is less synthetic than the previous one, right? So we use the Kafka producer performance test script, which is part of the Kafka distribution. So if you download Kafka in the bin folder, you will see the Kafka producer script, which is the script that can start the Kafka producer, and it will send a number of records to the Kafka cluster. Right, so we create a topic and we start the producer and we say that we want to send 15 million records to our Kafka server, Kafka cluster, right? And we start the Kafka cluster in the same way using the Docker Compose app, but we start in two different ways, right? We use the normal one, the default one, and we use the one that uses GraalVM Enterprise Edition Java runtime for running the Kafka broker. The results are approximately the following, and I got this on a few runs, so they're more or less consistent from this machine. And of course, the absolute numbers here do not mean anything. The Kafka broker runs in a small Docker container using 1 GB of heap, using a little bit of CPU, not very powerful. But the relative numbers, the difference in the relative numbers are important, right? So using GraalVM Enterprise for Kafka cluster for the broker, we get the better throughput for the producer, right? We get the better throughput for the producer, which is approximately 15 to 20% better than using the default environment that the content platform provides. And very importantly, we also get better tail latencies. The GraalVM Enterprise JIT compiler includes excellent just-in-time, excellent inlining and escape analysis. Right? And escape analysis specifically means that when you execute code, there are less objects are allocated on the code pass, and less objects allocated mean smaller pressure to the garbage collection. Smaller pressure to garbage collections means that there are fewer garbage collection cycles happening in your application, and that might mean that your tail latency, the maximum latencies, which is a very important metric in the real-time, any real-time sort of requirements, can go down. So you can see that here, the latency goes down approximately, quite a bit, 600 milliseconds compared to the default use case. And you can like the first experiment here, in both cases, is when the Kafka broker is not yet warmed up. So we can disregard that as a warm-up run. Right, so you can get better throughput using Kafka, using GraalVM Enterprise on the cluster by probably changing just a few lines in your Docker file. Last but not least, there is the Polyglot capabilities of GraalVM. Specifically for the Kafka use cases, that means two things. One, that being a high-performance runtime, Oracle GraalVM Enterprise Edition offers high-performance execution runtime for those languages. So potentially your Kafka gem, Ruby gem, could run faster using the Oracle GraalVM Ruby implementation, or say JavaScript, and you can just use those from those applications. But what you can also do, you can use the Polyglot aspect, and you can run Java Kafka client libraries, which are the latest and greatest and most supported Kafka client libraries, because Kafka is written in the JVM language, so Java libraries are the first thing that is compatible with the server, right? So you can use those Java libraries from other language environments. For example, if you have a Node.js application and you would like to use the latest and greatest Kafka client, you can use that on Oracle GraalVM using the interop between JavaScript and Java. Right. So all in all, GraalVM Enterprise gives you an opportunity to run your applications and make them faster, smarter, and leaner. And for Apache Kafka applications, that means that you can run your consumer and producers faster. It means that you can run them more efficiently in the cloud deployment environments with constrained resources. And you can also use the Polyglot features if you want to enable your applications in different languages, use other Kafka drivers. Thank you so much for coming to this webcast. And there are a number of resources that I would encourage you to visit. And this is the end of the content section.